Okay, so we're on to Unit 4, Day 3. Now, if you remember way back at the beginning of the semester, I mentioned, hey, there's going to be 2 times we do proofs. Now, and then when we get to triangles. Well, guess what? We're to triangles. So this is our second time to do proofs. So we're going to set up the properties of congruent triangles, and then we're going to prove triangles are congruent. Just a reminder about congruence. Geometric figures are congruent if they are the same size and shape. Clearly, a square cannot be congruent to a triangle. It's not the same shape. Congruent means same size, same shape. So, corresponding sides and corresponding angles are in the same position in polygons with an equal number of sides. So they're in the same positions. When we say they're congruent, we also have to put them in the same position. So if we look at our pictures here. Now, if you're watching this video, it's kind of easy to see. If you got handouts from the school and they're all in black and white, or you printed them and they're in black and white, it may not be as easy. But we want to first name the corresponding angles. On the screen, you can see the corresponding angles because they're in their corresponding colors. So we have A and D are corresponding. They're congruent to each other. That's what those marks in the corner also mean. So we can say that angle A is congruent to angle D. Then we look for the corners with 2 marks in there. Looks like that's going to be B and E. So angle B is congruent to angle E. And then last but not least, we have angle C congruent to angle F. So those are corresponding angles of our triangle. Then we have the corresponding sides. Again, the letters have to go in a certain order. So I'm going to name the first one, AB. So on my first triangle, I'm going from A to B. 2 marks to 1 mark, or red to blue. On my other triangle, I have to do the same pattern, red to blue. So DE is how I'll name this other one. Or if you look at what's in the corner, 1 to 2, 1 to 2. Now I'm going to go BC. So segment BC is congruent to, well, I did 2 to 3. So I'll do the same over here, 2 to 3. It's going to be E to F. So BC is congruent to EF. And then last but not least, I have CA congruent to, so I went 3 to 1, so I'll go 3 to 1. So FD. So CA is congruent to FD. Now, that's in a triangle. Let's just look at a polygon in general. In our case, it's a rectangle. So first, we need to name the corresponding angles. I'll just start with angle P. So angle P is congruent to angle W. Then we have angle Q. It's congruent to angle X. Angle R is congruent to angle Y. And then angle S is congruent to angle Z. So those are our corresponding angles within the two shapes. Now we need to do the corresponding sides. So I'm going to say segment PQ is congruent to segment WX. And then I'm going to say QR is congruent to XY. Then I'm going to say RS is congruent to YZ. And last but not least, SP is congruent to ZW. So there's our corresponding parts. So to name a polygon in the congruent statement. So what's a congruent statement? A congruent statement are these statements right here. So in the bottom one, polygon PQRS is congruent to polygon WXYZ. That's a congruent statement. Triangle ABC is congruent to triangle DEF. That's a congruent statement. Those are congruent statements. The order of the vertices indicates the corresponding or congruent parts. Notice P lines up with W. Those are congruent. Q lines up with X. Those are congruent. R lines up with Y. Those are congruent. S lines up with Z. Those are congruent. So yes, order matters big time. Okay, so they give us this statement. Triangle RST is congruent to triangle LMN. And then they ask us to identify the corresponding parts. Well, RS. So here's RS in this one. What two letters have to go with RS? LM. So that's what I would write there. Segment RS is congruent to LM. And I have T is congruent to N. So angle T is congruent to angle N. Then I have NM. It's congruent to TS. I have to put TS because N came first on the first one. They've got to be in the same order. Okay, so now they want us to work with congruent triangles for a little bit. So A asks us to find the value of x. Well, we're told these triangles are congruent to each other. In particular, H is congruent to H on the two triangles. So this H is 90, that means this H has to be 90. So how could I get x? 6x minus 12 equals 90. Add 12 to both sides. 6x equals 102. Divide by 6, and I get x equals 17. That's all I had to do. And just told me to find x. I found it. Then it asked me to find the measure of angle GFH. So that's this angle right here. Well, I know that E and G go together. E and G go together. So that means G has to be 21.6. This box right here tells me that's 90. So I can add 90 and 21.6 to get 111.6. Subtract that from 180. Get 68.4. And that's what that angle has to be, 68.4 degrees. So measure of angle GFH is 68.4 degrees. Okay, C asks us to find the measure of angle A. So here's A right here. They give us this 2x plus 6, but of course they don't want us to just say that. Now this one's kind of tricky. At first you want to say, oh, set them equal. No, we can't do that. We're told that that's a right angle right here, so that's 90. Which means this side has to be 90 degrees. So I have to use 5x plus 15 equals 90 to get x. 5x plus 15 equals 90 gives me my x. Subtract 15. I'll get 5x equals 75. Divide by 5, and I get x equals 15. Now, is that what they wanted me to find? No, they said find the measure of angle A. So to do that, I have to plug it in. Measure of angle A equals 2 times 15 plus 6, which is 36 degrees. There's our answer. So we had a few that we had to work out. Now let's get on to the fun stuff. Proofs. Wow. Let's move on to proofs. Okay, so these are going to be more fill in the blank type. So that way you don't have to write them all out. If you were in pre-AP, you would have to come up with this yourself. But we're not pre-AP. So I'm going to give y'all fill in the blank and give you hints on how to do these proofs. Okay, so as part of a proof, they're always going to have to give you something to start with. So we have 3 facts up here that are just given to us. So let's see what, as we go through this proof, let's see what they say. So angle P and angle M are right angles. That's given. P and M right angles, okay? R is the midpoint of PM. That's a given. So R is in the middle here. R is in the middle. PQ is congruent to MN. QR is congruent to NR. Okay. Prove triangle PQR is congruent to triangle MNR. That's our task. So let's look at the proof. They kind of started working it for us. Again, it's fill in the blank. Angle P and angle M are right angles. Where have we seen that before? That's up here in our given. So we're going to say given, and then we're going to check off this piece of information because we've used it. So if angle P and angle M are right angles, what does that mean? They're both equal to 90. That's one thing it means. But if they're both equal to 90, what are they? Congruent. So we can say that angle P is congruent to angle M. And that's by the right angles theorem. We didn't really learn it, but just again, RT stands for right, just so that I didn't confuse you. Essentially, the right angles theorem says all right angles are 90, and therefore they're all equal. All right angles are equal. That's basically what that says. Okay, next one. It says vertical angles. Well, where do I see vertical angles? Yeah, here's some vertical angles right here. So vert means vertical. In case you don't realize that. There's some vertical angles. So how would I name those? For the first one, I'm going to say PRQ. So angle PRQ is congruent to, well, I went right RQ. So on the other triangle, I have to go right, which is M, angle M, R, and then N. Notice I went in the same order. Right, the right angle, then R, and then our other angle. So now I've said two angles are congruent. Number 4, the reason is the third angles theorem, which we learned on the first day, Unit 4, Day 1, which says, okay, I've proved two are congruent, so that means the third has to be. We've talked about P, we've talked about R, talked about that one, talked about that one. The only ones I haven't mentioned are Q and N. So those two must be congruent. Angle Q must be congruent to angle N by the vertical angles theorem. Not vertical, what am I saying? Q must be congruent to N by the third angles theorem. I'm over here losing my mind. Step 5, R is the midpoint of PM. Do we see that anywhere on this page? No, we do. It's given to us. So this is given. So since R is the midpoint, it says, okay, fine. That means PR has to be congruent to MR. Why? That's our definition of midpoint. Back in Unit 1, we learned that's the definition of midpoint. If R is the midpoint, then each side's got to be congruent. Now, number 7 says it's given. So I'm going to look up in given and see what's the only one I have not used yet. I have not used PQ is congruent to MN and QR is congruent to NR. I haven't used those yet, so that's going to be that one. Now, all my givens have been used. So therefore, we've shown everything's congruent. So that means triangle PQR is congruent to triangle MNR by the definition of congruent triangles. So that's how we prove that two triangles are congruent. So there's that example. Now let's move on to our next example. Okay, so it again asks us to prove triangle JKL, which is the one you see in black, is congruent to triangle MLK, which you see in green. So it's fill in the blank, just like the last one was. So first, we say JK is perpendicular to KL, ML is perpendicular to KL. Where do we see that somewhere else on the page? Up in the given area. So this is given. There it is up there. Boom, boom. So we're told that JK and KL, JK is perpendicular to KL, and ML is perpendicular to KL. So these two are perpendicular. Which means, step 2, we say JKL, angle JKL, and angle MLK are right angles. Why? Well, because that's what perpendicular lines do. You told us that. Yeah, that's right. So we're going to say definition of perpendicular here. Definition of perpendicular. Lines. The definition of perpendicular lines tells us they've got to be right angles. So if they're both right angles, what can we say about them? That they're congruent. So we can say angle JKL is congruent to angle MLK by the right angles theorem. Right angles congruence theorem. So all right angles are congruent to each other. Okay, number 4. It says angle KLJ is congruent to angle LKM. Where do I see that? Appearing given. So this is a given. And then they tell us angle KJL is congruent to angle LMK. Well, let's see. I've talked about one angle. Talked about 2 angles. This is the 3rd angle that I've talked about. So what theorem should this be? This is the 3rd angles theorem. Okay, next step. JK is congruent to ML. JL is congruent to MK. I'll see that somewhere too. Up here again in the given area. So this is given. So then it tells us segment KL is congruent to LK. That's our reflexive property. And lastly, we've shown all the angles are congruent. We've shown all the sides are congruent. So that means the 2 triangles have to be congruent by the definition of congruent triangles. That's always going to be our last step when we prove triangles are congruent. That's always the last step. Okay, so that is our lesson for day 3. Stay tuned for the guided practice.